Okay, we can go ahead and get started. Good morning, everybody. It's just after 11. Welcome to today's Winter Fuel Outlook webinar. My name is Hannah Brule, and I'm the team lead for our short-term integrated products team in the Office of Energy Analysis here at EIA. As many of you know, EIA is a statistical agency within the U.S. Department of Energy. And EIA's mission is to provide independent and impartial data and analysis that can be used by industry, policymakers, researchers, and others to better understand how energy markets function and in turn make more informed decisions. Before I go over today's agenda, I wanted to review a few housekeeping items. This WebEx call is being recorded and may be posted on DOE's website or used internally. All attendees are muted and will not be able to share video during the webinar. However, if you have concerns, please drop off the webinar at this time. There will also be a Q&A period following the presentation, so you can submit your questions at any time using the chat function in the WebEx control panel. And this webinar will also be posted on EIA.gov after the event. In terms of our agenda, we're going to have EIA Administrator Joe DeCarolis go through the key findings from the report, and then we'll conduct a Q&A with several EIA experts who work on putting together the short-term energy outlook, including the winter fuels outlook. So with that said, I will turn things over to Joe to walk you through the report. Thank you.
Great, thanks, Hannah. Good morning, everyone. I'm really excited to be able to present this year's winter fuels outlook. And before I dive in, I just wanted to thank our staff for their effort to deliver this year's report and webinar, and I'm honored to be able to present the results. I also just wanted to recognize the importance of the winter fuels outlook. It speaks to really important pocketbook issues for families across the country. Next slide. So in the next 3 slides, including this one, I want to give you a high-level overview of the winter fuels outlook. The first is about what we do. So in the winter fuels outlook, we provide forecasts for the upcoming winter, focusing on residential energy expenditures. One thing I want to mention that's new in this year's edition is that we actually provide monthly expenditure estimates, not just for the whole season. We also help to contextualize those expenditures by looking at overall energy market conditions that could affect consumer spending on heating fuels in the coming months. Next slide. Our outlook covers 4 fuels. We have natural gas, electricity, propane, and heating oil. And what this plot is showing is forecasted expenditures relative to last year. And one thing that's really important to keep in mind is that the estimates represent total expenditures for the winter season. So for example, if you're looking at electricity, it's not just the amount of electricity, the spending on electricity for winter space heating, it's the total electricity bill for the season. You'll notice that for each of the fuels, we also include 3 different lines, and those represent 3 different temperature forecasts, and I'll give you a little bit more information about that later in the presentation. Here are the key takeaways. Our outlook this year is mixed, though we expect that most households will pay less. In our base case, households using natural gas will have lower bills this winter. Those using electricity and propane will see similar bills to last winter. And for those using heating oil, bills will be a bit higher than they were last year. Now, there's significant regional variation in our forecast. And there's also variation based on weather outcomes, as you can see in this graph. So the spread in the results is due to these different temperature forecasts. And again, we'll talk more about that later in the presentation. Next slide. Fuel inventories help us understand market conditions, and the outlook for fuel inventories is similar to the expenditure outlook, and it's mixed. So it's important to keep in mind that average demand for heating fuels in the winter tends to exceed production, and that's where inventories become very important sources of winter supply. So you can look at inventory levels relative to the average for a given time of year, and that can give insight into trends in production relative to consumption. We use a 5-year average inventory level as a benchmark when we're making assessments. And so here what you're looking at is the difference from the 5-year average. So when you see values on this chart that are greater than 0, that implies inventory levels that are above the 5-year average, and values that are below 0 are below the 5-year average. Looking across these three charts, you can see that natural gas and propane inventories are above the 5-year average going into the winter heating season. And by contrast, distillate fuel inventories, that's a broader category that includes heating fuel, is well below the 5-year average. Next slide. So there's three main factors that determine spending on space heating fuels. There's the household characteristics, weather, and then energy prices. The following slides are going to give a broad overview of those determinants for this winter, and then we'll have a more specific discussion on each of the four main heating fuels. One thing I want you to keep in mind is that the measures that we're presenting are very broad, and they're based on each of those four fuel types and across 4 different regions of the United States. If you're trying to determine household spending for an individual household, that's going to depend a lot on the size of the home, the efficiency of the equipment within the home, the settings of your thermostat, as well as other conditions. So we're just providing regional averages here. Next slide. The heating fuel used in a house is, of course, a major determinant of expenditures, and heating fuels are not used uniformly across the country. So let me explain what you see in the figure here. On the left side, the legend indicates the share of homes within each state by color that use a particular type of fuel, and the darker the color, the higher the number of households that use that fuel type. The map shows the distribution of primary fuels used for home heating across the country. And then the bar at the bottom shows national average shares of primary heating fuels by fuel type. So natural gas is the most widely used heating fuel. 46% of homes use that as their primary source of heat. Electricity is predominant across the South, and across the US, it's used in about 41% of homes. Propane is used mostly in northern states and constitutes about 5% of households, and heating oil is predominantly used in the northeastern United States and represents about 4% of households. Again, remember, we forecast expenditures based on region, not at the state level. Next slide. This slide provides some more detail on fuel use by region, so let me walk you through this graphic. Looking across the top, we have the regional breakouts for each of the 4 census regions that we track. The numbers in gray near the top represent the share of households within each region. If you look down the left side, those are the share of households by primary fuel. So that's what we were just talking about on the previous slide, those percentages. The circles are proportional to the absolute number of households using a given fuel within a given region. And then down the right side, that's the number of regions where we provide estimates. So just a few insights here. Homes that heat primarily with natural gas or electricity together make up about 87% of US households. With propane, we cover 3 regions based on the distribution of households. For heating oil, we report the US average, but over 80% of the homes using heating oil are in the northeastern United States. So our forecast is roughly equivalent to a forecast for the Northeast. Altogether, the winter fuels outlook covers 95% of homes in the United States. Next slide. As I noted earlier, the total winter expenditure data we show represents all uses for each primary heating fuel. It's not just the portion attributable to heating. And you can see that in a little bit more detail in this graphic. The dark green part of the bar shows expenditures for the main heating fuel on heating. The lighter green part shows expenditures for the main heating fuel on non-heating uses. And then the gray bar shows expenditures on other fuels, okay? So take electricity as an example here. You can see that the bar is mostly green. And what that indicates is that homes that are using electricity as their main source of heat, electricity is their main energy expenditure during the winter. There's not a lot of supplemental fuel use. By contrast, if you look at the other fuels, take propane as an example. If you heat your home with propane, You still have energy expenditures on other sources, particularly electricity, right, for your lighting and for appliances, and that's represented in the gray here. Next slide. Also, in this edition of the Winter Fuels Outlook, we've changed our definition of the winter season. It used to run October through March, and in this edition, we've dropped October because October only accounted for about 6% of the heating demand over the past 10 years. In the graphic here, you can see that the units are heating degree days, and that's a proxy for heating demand. The way it's calculated is you take the difference between the average daily outside temperature and the indoor temperature, and then you sum those differences for all the days in a month, and that's how you get the numbers that are shown here in the chart. Next slide. Of course, weather is an important variable in our forecasts, and what this figure shows is forecasted in actual heating degree days over the last decade. The dots represent the beginning of the season forecast. The blue line represents the actual heating degree days for that winter. And then the bars represent alternative weather forecasts where we increase and decrease the heating degree days by 10%. And you can see that that captures most of the variation between predicted and observed heating degree days. And so if we increase the heating degree days, that implies a colder winter. If we decrease the heating degree days, it means less heating demand in a warmer winter. Moving into this winter, we expect no change from last year. So it's going to be very similar. It is, when you look over a longer history, we're forecasting that this winter is going to be a little bit warmer with about 4% less heating degree days compared with the 10-year average. Next slide. Prices, of course, are a big determinant of expenditures. And here we're looking at the unit prices over the last 3 decades. In general, we report prices in nominal terms because we're looking just between last winter and this winter. But here, because we're looking over a longer period of time, we report both real and nominal prices. The real prices remove the effects of inflation, and that can be helpful when you're looking over a long time period like this. If we look at what's been happening recently with natural gas and heating oil, we saw a sharp rise last year, followed by a decline this year. And for electricity, prices also rose last year, but have remained relatively flat this year. Next slide. Okay, in this slide, we show the link between wholesale and retail prices, and I'm going to start on the left with natural gas and then move to the right. One thing to keep in mind is that natural gas has slow pass-through from wholesale to retail markets, meaning that a change in the wholesale market takes a while to be realized in retail markets, and that's largely due to the nature of gas utility regulation. The impacts that pass-through can vary significantly by state and even by utility within a state. But you can see that over longer periods, changes in natural gas wholesale and retail prices are pretty closely correlated. This winter, we expect natural gas prices for residential consumers to be down more than 20% from last winter. So that's a big drop. Moving on to electricity, the pass-through dynamics are similar to what they are for natural gas. You can see that the retail prices have less volatility than the wholesale market prices in the lighter color there. We expect that electricity prices for residential consumers we forecast that they're going to be down about 2% this winter. And that largely reflects a big drop in the price electric utilities are paying for natural gas, which is widely used as a source of electricity in the United States. Moving on to heating and propane, those price changes from wholesale to retail markets, those price changes can happen very quickly because they're not regulated in the same way as natural gas and electricity. We can see price changes in the wholesale market be reflected in the retail market over a period of 4 to 6 weeks. And you can see how retail prices track wholesale prices pretty carefully in the charts here. With propane, we forecast that residential propane prices will be 7% lower on average across the country this winter. And with heating oil, we forecast that residential heating oil prices will be 2% lower this winter. Next slide. So let's revisit this figure from earlier in the presentation. Remember, expenditures are going to be the product of prices and the consumption level. And weather affects expenditures in two different ways. The first is weather affects consumption. So for example, if we have colder temperatures, that's going to increase demand. And second, consumption in turn can affect prices. Again, if we have colder weather, that will draw down fuel inventories and that can push prices up. And you see the strongest effect here on propane, where demand is largely driven by winter heating. So you can see how much higher that cold weather forecast is above the other two scenarios. Remember, price pass-through, which we just talked about, also plays a role here. The translation of changes in the wholesale to retail markets is relatively slow for natural gas and electricity, so you have relatively narrower bands, and it's relatively fast for propane and heating oil, and that contributes to the wider bands. The last thing I want to mention is with respect to electricity, remember, we're looking at total expenditures for electricity, and we have a lot of electricity demand in our homes that isn't related to space heating and isn't related to temperature, and therefore it's less sensitive to changes in temperature. Next slide. Now what I want to do is go through and look a bit more closely at the outlook for each of the four fuels, and we'll start with natural gas. Just to reorient you, the darker colors show higher shares of households using natural gas. And also remember, natural gas is the primary heating fuel for 46% of households in the United States. Next slide. So for each of the fuels, I'm going to show you a slide like this with the same format. So what you have here is the US average on the left and all four regions on the right. The circle in the upper left of each figure shows the base case expenditure this winter. So that's the total dollars expended for the entire winter on that fuel in the base case, as well as the percent change from last winter. Now, as I mentioned at the beginning, we're now providing monthly values in this report, and this is the first example where you can actually see the forecasted expenditures month by month. The dotted line represents last winter, and the three solid lines represent our base forecasts and our other temperature sensitivity cases. The takeaways for natural gas are that we expect households, again, on average, nationally, to spend about $600 on gas this winter. That's down more than 20% from last winter. Across all the modeled cases and regions, we expect expenditures to be down compared with last winter. And we see this effect is most pronounced in the West, where last winter was very cold, and we expect a milder winter this year. Next slide. Okay, this slide shows the supply and disposition of natural gas, and it helps to shed some light on the underlying price dynamics. On the left, we have supply, which includes production, imports, and withdrawals from storage. And on the right, we have disposition, basically where the natural gas is going. That includes consumption, exports, and injections into storage. The bottom panels show the change in supply and disposition with the same month a year ago. So let's start with the differences in supply on the bottom left here. You see those negative blue bars right near the beginning of the time series? Those represent lower inventory draws this past January and February compared with the year before. Last January and February, particularly on the East Coast, was very mild, and so we were able to draw less natural gas out of inventory. That allowed our stocks of natural gas to rise, and that pushed down natural gas prices. The other thing is you can see in orange there that natural gas production has grown this year, although at a slowing rate. And we've had this growth in natural gas production despite a significant drop in natural gas prices, because the natural gas is largely associated with oil production in the Permian Basin of Texas and New Mexico, and that production is not particularly sensitive to natural gas prices. On the disposition side, I'm looking at the bottom right here. Consumption, particularly in the electricity sector, as well as LNG exports, have grown over the past year, but supply growth has kept inventories above the 5-year average. And so this dynamic between supply and disposition has kept natural gas prices relatively low this year. Next slide. This is looking at natural gas inventory levels across the 4 regions. The gray line represents the 5-year average, which is, as I mentioned, a common benchmark for comparison. And the dark red line indicates inventory levels over recent history. First thing you notice is that there's a very clear seasonal pattern to the inventory levels. Inventories typically build from April through the end of October or early November, and they provide this part of the supply for winter. Take a look in particular at the South Central region. You can see that for most of the last year, past year, we were below the 5-year average, but this year the opposite is true. Inventory levels have been above the 5-year average. And again, that helps to explain these lower natural gas prices. Next slide. Okay, I'm going to move on and talk about propane. 5% of households nationally use propane as their primary heating fuel, and that's mostly concentrated by homes in the upper Midwest, which you can see by that darker yellow there. And even though the total number of households using propane is relatively small, it's one of our highest concerns because cold weather increases demand, and that can have a market effect on prices. Next slide. On average, we expect spending on propane will be down slightly this year, but there are regional differences. The lower national average is being driven by the Midwest, where prices are down more than 10% from last winter. Prices in the Northeast and the South are down slightly from last year, but we expect higher consumption in the forecast, and that leads to a slight increase in expenditures. Among the fuels that we look at, propane sees the strongest increase in the cold scenarios, and that's driven by what happens in the Midwest. So if you look at the Midwest chart, you see that darkest line at the top. That's the cold temperature scenario, and you can see how much higher the expenditures are in that case compared with the other two. Prices in the Midwest can spike in the case of very cold weather, because there are long supply chains required to bring supplies into the region, often by truck or rail. Next slide. I also want to mention that beginning last month, we're now publishing a propane spot price forecast for Mount Belvieu, Texas. We watched the propane market very carefully given the price sensitivity. You may remember that in the winter of 2013 and 2014, there was a propane shortage. There was a cold snap across the Midwest. They got hit with cold temperatures, and that led to record high propane prices. This winter, we expect propane to average about 76 per gallon, and that's down slightly from last winter. Next slide. This is the same format for supply and disposition. Again, this time looking at propane. Inventory withdrawals are required during the winter to meet heating demand. So you can see that on the top left, we were withdrawing during the winter in order to meet that increased demand. On the disposition side, looking at the top right, you can see that consumption exhibits a clear seasonal pattern and that also export levels of propane are significant. The takeaways for propane are that supply and disposition for propane are actually quite similar to natural gas. And in fact, the production is linked. The second thing is that warmer winter, this past winter has left inventories high, and that's contributed to the price dynamics that we're seeing. So again, slightly higher production, higher inventory levels have kept prices down this year. Next slide. I want to emphasize propane inventory levels matter a lot. So we're looking at inventory levels across all 4 regions. Notice that almost all of the excess to the 5-year average is located in the Gulf Coast region. These inventories are not cheaply or quickly available to the major propane consumption centers in the Midwest. Once those barrels move south, they're very hard to move back north again. If you look at stocks in the Midwest, they're close to the 5-year average. So if the weather in the Midwest is normal or perhaps a little bit colder, it shouldn't pose any problems. But if there's a severe and prolonged cold snap in the Midwest, there would be a need to pull inventories from the Gulf Coast, and that could cause propane prices to rise. Next slide. Next, we'll talk about heating oil. So again, 4% of households nationally use heating oil as their primary heating fuel. And the majority of those homes, as you can see in the map here, are concentrated in the northeastern United States. Next slide. Again, as a reminder, we only provide a US average for heating oil, but because most of that consumption is in the Northeast, it's effectively a forecast for the Northeast as well. Baseline heating oil expenditures, we expect to be up 8% this winter based on colder weather in the Northeast. We expect, though, that the forecasted heating oil prices are down a bit this year due to lower refining margins compared with last year. So that helps to keep expenditures a little bit lower. And then, of course, this is going to be dependent on crude oil prices, which are uncertain. Next slide. Let's take a closer look at those refining margins that I just mentioned. So refining margins are indicative of refiner profit margins. In order to take a closer look, we can look at diesel crack spreads. Those crack spreads are a good proxy for refining margins. And note that diesel would include fuel oil used for heating. So what are crack spreads? Crack spreads are the difference between the price paid for the crude oil and the price for the refined products produced with the crude oil. And again, it's indicative of profits over the short term by refineries. You can see in the chart that both wholesale prices and crack spreads are down this year compared with last year, but they're still relatively high, and those high spreads incentivize refiners to produce more. Next slide. Here's the supply and disposition of distillate. Again, keep in mind that heating oil is only part of this larger distillate category, which includes diesel fuel used by vehicles. So there's a less discernible seasonal pattern associated with winter heating here. This shows distillate inventories, and they're consistently below the 5-year average on both the Gulf Coast and especially in the East Coast region. And there's a couple of reasons for that. There's structural tightness in the distillate market following Russia's invasion of Ukraine. And there have also been some refinery closures on the East Coast that have also left distillate inventories low. Okay, finally, next slide. We'll talk about electricity. 41% of households nationally use electricity as a primary heating fuel, and the highest concentration is in the southern states. Next slide. On average, we expect electricity expenditures to be similar to last year. We expect expenditures to be up slightly in the Northeast, in the South, down slightly in the Midwest. And in the West, we're expecting warmer weather than last winter, and that leads to a significant decline. There's less variation across the weather cases, again, because remember, electricity is used for much more than just winter heating. So the overall expenditures for electricity during the winter are going to be less sensitive to temperature. Next slide. With electricity, there's a couple additional things that I want to point out. The first thing is that there are several different heating technologies that can make use of electricity. They're generally broken down into resistive heating technologies as well as heat pumps. They have very different efficiencies. In our report, we don't look at differing expenditures based on technology type, but just to know that the household expenditure for a particular home will be dependent on the equipment type. And then the other thing about electricity is that it's often used as a secondary source of heat. So for homes that heat with propane or natural gas or heating oil, it's quite common to have a portable electric heater, which is indicated by the blue bar in the right-hand chart. So electricity gets used pretty frequently for winter heating. And with that, I'm done with my presentation. I did want to make note that we have several resources at EIA related to winter fuels. So next slide. I'm not going to go through these in detail, but we do provide week-to-week and month-to-month update through some of our products. They're hyperlinked here, and they're also available on our website. And with that, I'm going to turn it back to Hannah for the Q&A session.
Great, thank you, Joe. That was a lot of information. Appreciate you going through that. So next up, we're going to introduce our panel of STIO experts. If you could go to the next slide. So joining me, we'll have Tim S., our STO product manager, and analysts, including Josh, who works on our propane forecast, Matt French, who works on the liquid fuels and the distillate outlook, Tyler Hodge covering electricity, and Karina Ricker on natural gas. So before we dive in on this, yes, we will be posting the slides to EIA.gov shortly after the event concludes. And this has come up in the chat a few times about when we've changed the definition of winter to remove October. Yes, we did go back and recalculate the prior year estimates. So those comparisons are consistent across the years. So diving into the Q&A, let's start with you, Tim. Can you talk about how the El Nino factors into the forecast?
Yeah, thanks, Hannah. That's actually a really good question and a big source of uncertainty for our forecast for this winter. Our forecast uses a 30-year trend in heating degree days, which has been, so it doesn't factor in the potential for annual climate variations like El Nino, which, like I said, makes El Nino a source of uncertainty for our forecast. The current indications from NOAA indicate a high probability that an El Nino climate pattern would affect weather in the United States this winter. And so what does that mean for household energy expenditures? The effects of each El Nino are of course different, but NOAA notes that El Nino in general acts to tilt the odds toward weather that is cooler than average across much of the South and towards drier and warmer conditions in many of the northern regions of the United States. So again, I would say that it just right now is a source of uncertainty in terms of weather in our forecast.
Great, thank you, Tim. My next question is for Matt. Can you talk a bit about the distillate supply situation in Europe currently and how that compares to this time last year?
Yep, absolutely. Good morning, everyone. So heading into last year's winter, well, let me back up and say that in Europe, they use diesel fuel for peak electricity generation, which is then used for heating supply. And so that's kind of how it factors into the winter fuels outlook here. Right now, I look at stocks in the Amsterdam, Rotterdam, Antwerp, or the ARA region a lot. And right now, stocks of distillate in the ARA region are slightly above where we were last year. They've been trending down over the past couple of months, but we've recently seen some upticks in prices in the ARA region. So I wouldn't be surprised if we might see that trend shift around a little bit. So heading into last year, there was a lot of concern about where the supplies would be coming from. And what we've seen is that there was a lot of increase in distillate imports into the ARA region, into Europe, and a big increase from the Middle East and also from Asia. And further on that note, there's been at least 2 refineries coming online. The Al Zour refinery, which had come online fully in April. That's a 600,000 barrel a day refinery, had come on fully in April. They had some technical issues, and I believe it's supposed to be coming back online to full operations this week. And the second one is the Duqm refinery. That's also in the Middle East, and that is scheduled to come online before the end of this year. So both of those refineries could provide an extra source of diesel imports into Europe. Looking at the inventory side of things, I talked about the ARA side. Inventories are slightly higher than we were at this time last year. On the US East Coast, kind of a similar story. They're low compared to the previous 5-year average, but we're slightly higher than we were at this time last year. So overall, compared to last year, where inventories are slightly higher, we've got some additional sources kind of coming online, and we've got the trade routes that were a bigger concern last year. The markets have sort of figured some of that out, but it is still a very dynamic market. There was the Russians' export ban on diesel, which they subsequently lifted. So there's, in general, things are a bit more settled than we were last year, but I would say that is definitely still a highly dynamic market.
Great, thank you, Matt. Speaking of dynamic markets, Karina, could you speak to some of the biggest sort of risk factors that you see in the coming months with regards to natural gas markets?
Sure. So weather and temperatures are always a big source of uncertainty for our natural gas forecast, and especially during the winter season because so much natural gas is used to heat homes across the United States. And we try to capture some of that uncertainty with the 10% colder and warmer scenarios that we include in the winter fuels outlook. But something we don't model are extreme, acute winter weather events. For example, a couple of years ago in February 2021, there was a winter storm that impacted Texas and some Midwestern states that had impacts both on the supply and demand side for natural gas. And as a result, we saw regional natural gas prices rise a lot and quickly. Some regional natural gas prices were hundreds of dollars per 1,000 cubic feet, in some cases approaching $1,000 per 1,000 cubic feet. And those prices, even though they declined back to where they were prior to the winter storm relatively quickly, those high prices were very consequential for consumer bills for natural gas. And that type of event is not something that we model in the STIO, and it's a big source of uncertainty for our forecasts.
Absolutely, that's a really good point. Josh, could you speak a bit or talk about demand expectations for propane outside of space heating? So specifically, how much grain grind demand do you expect, and how do you see exports shaping up this winter?
Yeah, definitely. So just for context, for people that don't necessarily know the propane market, you may be wondering why corn, how that relates to winter heating. The corn harvest sort of overlaps with the winter, especially in November, and that could provide a significant source of demand for propane. So propane is used in commercial grain dryers. The Department of Agriculture right now is showing that the corn harvest is well ahead of schedule, and the quality of corn is pretty poor. So we can expect that there won't be that much grain drying demand, and therefore low propane demand in November. And then as far as exports are concerned, right now there's a pretty wide spread between US prices and prices in East Asia, and to some extent Northwest Europe. However, that spread has been narrowing recently, so exports could be a bit slower at the beginning of the winter, from now until November, but I guess relative to previous years, it could be higher. So it could be slowing down from the summer going into winter. And then looking into the rest of winter and going into 2024, we can expect that there should be pretty high propane exports, especially considering winter demand in the other regions, and the lower US prices compared to East Asia and Northwest Europe.
Great, thank you, Josh. Jumping back to Tim with another sort of weather methodology question, can you talk about how using the 30-year range sort of impacts the forecast for the HDD?
Yeah, so I noticed a couple of questions on that come through the chat, and I think one of the things to emphasize is that it's a 30-year. We use a 30-year trend, not the 30-year normals or 30-year average. There's an important distinction there. So what our methodology is we take historical heating degree day information from NOAA by state, and we run a regression looking at a simple trend over 30 years, and then along with population weights over those 30 years. And then for the forecast, we use that equation to continue that trend over the next, in this case, 1 year, because we really only have, sitting here at the end of 2023, we really only have 1 year of forecast left. So we use that equation to forecast by state the next year's worth of HDDs by month. And then we use population forecasts from the S&P Global macroeconomic model for the United States, and then aggregate those heating degree days by state level population up to the regional level and then to the US level. So that's how we come up with our current forecast, which again, you'll notice that compared with last winter, the heating degree days using this methodology get us about the same number of heating degree days compared with last winter, but there are slightly fewer heating degree days. I think 4% fewer than the 5-year, or 10-year average. And while I'm on weather, I did see one more question about El Nino come in there. And so again, we don't include El Nino specifically in our forecast. We're using these trends. So we don't have, EIA ourselves do not have any view on whether an El Nino will affect temperatures in the November, December, January period. We only mention it to highlight the fact that it is a potential risk to the forecast.
Great, thanks, Tim. So we are running short on time, but I just wanted to ask one final question to Tyler about how growth in renewables might affect residential electricity bills.
Thanks, Hannah. Yeah, that is kind of a complicated question, so I'll try to keep the answer pretty short here. But in terms of like the most direct effect, retail bills that people pay are really broken into two components. There's the cost of producing the electricity, generating it, and then also the cost of delivering or transmitting that power to consumers. So the most direct effect of the increase in renewables would probably be seen through the delivery side, specifically the transmission side, because with the new build out in renewables, we're seeing a lot more spending and investment in transmission to get the renewables to the demand centers. But on the other side, with electricity generation, there's a bit of an indirect effect too, because generation costs are generally determined by the most expensive unit or generator needed to produce power. And for at least the near term, that would still be natural gas. So one of the benefits of having increased renewables is that there's less need to generate from natural gas. So like for the next winter months, that might help mitigate some potential price spikes in the wholesale markets for power if we see like some constraints on natural gas delivery or something like that. So I think that's probably a good summary of the overall effect of the increase in renewables.
Yeah, that's wonderful. Thank you, Tyler. I wanted to thank all of our panelists here, and a special thanks to Joe for sharing our results here and walking through the presentation. And thanks to all the analysts that support the STIO. Thank you all for joining us today. As I said, these slides will be posted to our website shortly, and a playback of this video will be made available later as well. So that concludes our event. Have a great day. Thank you.